Today we solve next question. See the question. Solve the following equations by inversion method. First problem we solve in previous part. Today we solve third example from that. Given equation is 2x plus 6y equals to 8, x plus 3y equals to 5. We have to find solution of these two linear equations by using inversion method. So we have to find its matrix form first. So we write these two equations in matrix form as the given equation can be written in the matrix form as. First we write the coefficient matrix. So coefficient of x is 2, here coefficient of x is 1. So in first column we write the coefficient of x, in second column we write the coefficient of y. Coefficient of y is 6, coefficient of y is 3. So we write 6, 3. This is variable matrix and this is constant matrix. Constants are 8 and 5. Variable are x and y. So this is the form Ax equals to b where 2, 6, 1, 3 is constant matrix. Constant matrix we denote here by A. XY, this is variable matrix, we denote it by capital X. This is constant matrix which we denote by capital B. Now we have to find the inverse. Before that we have to check its singularity. So we have to find its determinant first. Determinant of A is equals to determinant of this 2163 which is equals to 0. Therefore inverse does not exist. If inverse does not exist, hence x and y do not exist. That means we do not get the solution of that equations. The next question is solve the following equations by the reduction method. First equation 2x plus y equals to 5, 3x plus 5y equals to minus 3. For solving this problem, we have to write this equation in matrix form first. So we write in matrix form. In first matrix we write the coefficients. In first column we write the coefficient of x. Coefficient of x is 3 here. Coefficient of x is 3 here. Coefficient of y is 1 here. Coefficient of y is 5 here. Into variable matrix. Total number of variables are 2. Now in RHS we write the constant matrix. Constants are 5 and minus 3. 5 minus 3. Now we have to solve this problem by reduction method. So we have to reduce this coefficient matrix in upper or lower triangular matrix or diagonal matrix. So we write in any place we have to make 0. So here if we want to 0, we multiply this first row by 3. So 3 into 2 6 and this matrix this row by 2. So in this way by multiplying first row by 3. So 3 into R1 multiplying this second by 2, that is 2 times R2. If we take difference, so we write this in first row. 3 into R1 that is 6, 6 minus 6, 0. 3 into R1, R1 is 1, so 3 into 1 is 3, so we write here 3, minus 2 into R2, 5 into 2 that is 10, that is 3 minus 10. Keep the second row as it is, 3, 5, variable matrix as it is. Same elementary transformation we have to apply on RHS. 3 into R1 that is 3 into 5 is 15. So we write here 15 minus 2 into R2. R2 is minus 3 minus minus plus, that is plus 6. Second row element as it is. So 0 minus 7 3 5 x y. Here 21 minus 3. If you observe, if we consider this diagonal, then the element above this diagonal is 0. So this is lower triangular matrix. After reducing it to lower triangular matrix, we have to write in linear form. Therefore 0 into x, that is simply we write minus 7y is equals to 21 equating the second. Here we write 3x plus 5y is equal to minus 3. After simplifying, we get y equals to minus 3. If we replace y equals to minus 3 in this equation, we get 3x minus 15 is equal to minus 3. Therefore, 3x is equal to 15 minus 3, which is equal to 12. That means x is equal to 4. Now same problem we solve, reducing this element 2 by 0. In first, in place of 2, we reduce it to 0. Now instead of this 2, you reduce in place of 3, we get 0 by applying this elementary transformation. Use the same procedure. The given equation can be written in the matrix form as, so we write in matrix form by multiplying 2 to second row elements. So we get here 2 into 3 6, 5 into 2 10, here on RHS minus 3 into 2 minus 6. Now in place of 6 we reduce it to 0. So R2 minus 3 times R1, R2 is 6 here, R1 is 2, 3 into 2 6, so we get here 0. After reducing this matrix to upper triangular matrix, write in equation form. So we write here 2x plus y, 2x plus 1 into y, that is 2x plus y, 0 into x, which is 0, 7 into y plus 7y equals to, by equality of matrix. By equality of matrix, 2x plus y equals to 5, 2x plus y equals to 5, 0 plus 7y is 7y equals to minus 21. Therefore, substituting y equals to minus 3, from this 7y equals to minus 21, we get the y is minus 3. Substituting y equals to minus 3 in equation 1, we denote this by equation 1 and this by equation 2. So after substituting, we get the value x equals to 4. Hence x equals to 4, y equals to minus 3 is the required solution. म्हणजे या दोन्ही प्रॉब्लेम तेच आहे, या दोनही मेथडमध्ये तुम्हाला सेम आन्सर मिळालेला आहे. नाउ सी द नेक्स्ट एक्झाम्पल. इक्वेशन्स आर x plus 3y equals to 2, 3x plus 5y equals to 4. So first we write in matrix form. The given equation can be written in matrix form as, this is coefficient matrix. Coefficients are in first column 1 3, 1 3, 3 5, 3 5. Variables are x and y, so write variable matrix, and constants are 2 and 4. Now we have to reduce this coefficient matrix to upper or lower triangular matrix. Here is 1, so we reduce is 3 by 0. For that we use elementary transformation. R2 minus 3 times R1, we get here R3, R2 is 3, R1 is 1, so we multiply this first row element by 3, so 3 minus 3 is 0. Keep the first row element as it is, 1 3 as it is, so 3 minus 3 is 0, R2 is 5, 3 into 3 is 9, 5 minus 9 which is minus 4. So for elementary transformation in RHS, we write R2 is 4 here, R1 is 2, so 3 into 2 6, 4 minus here R2 is 4, 4 minus 6, so we write here minus 2. Keep the first row element 2 as it is. Now after writing this in equation form, first equation is x plus 3y, second equation is 0 into x is 0, so we write 0 minus 4y, 0 minus 4y. By equality of matrices, first equation is x plus 3y equals to 2, and second directly we write minus 4y equals to minus 2, minus 4y equals to minus 2. Denote this as equation number second, this is equation number 1. So after solving it, cancelling minus sign on both sides, after dividing 2 by 4, we get y equals to 1 by 2. Substituting y equals to 1 by 2 in this equation, so in place of y, we replace here 1 by 2, so we write here directly 3 into 1 by 2 is 3 by 2, so x plus 3 by 2 equals to 2. after transferring this 3 by 2 on RHS, which get minus x is equals to 2 minus 3 by 2 after cross multiplying 2 into 2 is 4, 4 minus 3 is 1, so we write 1 by 2. Hence x is equals to 1 by 2, y is equals to 1 by 2 is the required solution. In previous example, we reduce in place of this first element 0 to do yourself by taking the elementary transformation as 3 into R1 minus R2. We have to change this, so check yourself. Now see the word problem. The cost of 4 pencils, 3 pens and 2 erasers is rupees 60. The cost of 2 pencils, 4 pens and 6 erasers is rupees 90. Whereas the cost of 6 pencils, 2 pens and 3 erasers is rupees 70. Find the cost of each item by using matrices. म्हणजे आपल्याला मॅट्रायसेसचा यूज करून ते प्रॉब्लेम सॉल्व करायचा आहे. बिफोर दॅट वी हॅव टू राईट दिस प्रॉब्लेम इन लिनियर इक्वेशन फॉर्म. We have to find the cost of each item. Items are pencil, pen and eraser. Suppose we consider the cost of pencil is x, cost of pens is y, cost of eraser is z. So let the cost of one pencil, one pen and one eraser be rupees x, rupees y and rupees z respectively. So from according to given conditions or from the given conditions, 4 pencil, 3 pens, 3 eraser is rupees 60. Now the cost of 1 pencil is rupees x. So the cost of 4 pencil is 4 into x. Cost of 3 pens is 3 into y. Cost of 2 eraser is 2 into z. So the total cost is 4x plus 3y plus 2z equals to 60. In second condition, the cost of 2 pencil, 4 pens and 6 eraser is rupees 90. So according to our consideration, 2 pencil cost is 2x, 4 pens cost is 4x, 6 eraser cost is 6z. So we write 2x plus 4y plus 6z equals to 90. Taking 2 from left hand side, we reduce it to x plus 2y plus 3z equals to 45. Now from third condition, cost of 6 pencil is 6x, cost of 2 pens is 2y and cost of 3 eraser is 3z. So for given condition we write 6x plus 2y plus 3z equals to 70. Now we have to solve these 3 linear equations by using matrix method. So now this problem convert to our previous form. There these 3 linear equations are given already. Now we have to solve these 3 equations. Now we are free here to solve by inversion method or by reduction method. So we write these 3 equations in matrix form as. Now we have to reduce this coefficient matrix into upper triangular matrix or lower triangular matrix. So we first write given equation in matrix form. Now observe the elements. Element in second row, here is 1. Now this one required in place of this 4. So for that we interchange these 2 rows. So we first apply the elementary transformation as R1 interchange with R2. After applying this elementary transformation, element in second row we write in first row, element in first row we write in second row. Same elementary transformation on RHS, element in second row we write in first row, element in first row we write in second row. Now after applying this elementary transformation, we require in place of 4 0, in place of 6 0. So we take the first row for this calculation. So we write R2 minus 4 times R1. So 4 minus 4 is 0 here. Now In place of 6 we require 0, so we write R3 minus 6 times R1. So we apply these two elementary transformation for getting 0 in place of 4, getting 0 in place of 6. Now after applying this elementary transformation, we require 0 in place of minus 10. For that we use the second root. Now sign of both the elements are same, so we do the subtractions. R3 minus 2 times R2, because R3 is minus 10, R2 is minus 5. Minus minus get plus, so 10 minus 10 plus 10 we get here 0. So we apply this 3 elementary transformation. Calculation you can do yourself. Now after reducing these elements 0, 0, 0, we write the equations. So the first equation is x plus 2y plus 3z equals to 45. Second equation, this element 0, so we write 0 minus 5y minus 10z equals to minus 120. Then 0, 0, so we write 0 plus 0, here is 5z, so 5z. Then after equating by equality of matrices, we write this x plus 2y plus 3z equals to 45 minus 5y minus 10z minus 120 equals to minus 120. Last is 5z equals to 40, 5z equals to 40. Now substitute this z equals to 8 in equation second, we get the value of y. So after substituting z equals to 8 in equation number second, we get minus 5y equals to minus 14, therefore y equals to 8. Now substitute the value of z, substitute the value of y in equation number 1, we get the value of x. So after substituting and simplifying, we get x equals to 5, therefore x equals to 5, y equals to 8, z equals to 8. In this way we calculate the cost of pencil, pen and eraser. Now see the example number 4. If 3 numbers are added, their sum is 2. If 2 times the second number is subtracted from the sum of first and third numbers, we get 8. And if 3 times the first number is added to the sum of second and third number, we get 4. Find a number using matrices. Now we have to take that 3 number first, that we take x, y, z. Let the numbers be x, y, z according to given condition. Their sum is 2, so we write x plus y plus z is equals to 2. We are given second number is subtracted twice by taking the sum of first and third number. So we write x plus z minus 2y equals to 8. Rearrange them first. So we write this minus 2y at second position. So we write x minus 2y plus z equals to 8. Now according to third condition, we add the first number by taking its thrice to the sum of second and third number. So we write here y plus z plus 3x equals to 4. This is also from according to condition. So rearrange them. 3x plus y plus z equals to 4. Hence the system of linear equation is. So write these 3 equations. X plus y plus z equals to 2. X minus 2y plus z equals to 8. 3x plus y plus z equals to 4. Now from these 3 equations, we have to write these 3 equations in matrix form. So the matrix form is, write the coefficient matrix. Coefficient of x is 1, 1, 1. Sorry, here 3. So we write in first column 1, 1, 3, 1, 1, 3. Coefficient of y are 1, minus 2, 1. So we write 1, minus 2, 1. Coefficient of z are 1. So we write 1, 1, 1. Then variable matrix in constant 2, 8, 4. So we write here 2, 8, 4. Now we have to reduce this matrix either to upper triangular or to lower triangular or diagonal matrix, or you can solve this problem in another method. Now in previous example we reduced in place of 1 0, in place of 3 0, in place of this 1 0, that is into upper triangular matrix. Now in some problem there is no need to reduce it into upper or lower triangular matrix. In this example, here in place of 1 we reduce it to 0, in place of 3 we reduce it to 0. While applying this elementary transformation, here we get 0. So the second row, after writing into equation form, we get in terms of y only, and last equation in terms of y and z. So this second equation in terms of y, this third equation in terms of y and z, and this first equation in terms of x, y, z. So there is no need to reduce this -2 to 0. So we apply elementary transformation R2 minus R1 for reducing this 1 to 0. So 1 minus 1 is 0. You can check the remaining element. Now instead of this 3 we require 0. So for that R3 minus 3 times R1, R3 is 3, R1 is 1. So 3 minus 3 into 1 is 3, 3 minus 3, 0. While applying this elementary transformation we get here 0. So there is no need to apply additional elementary transformation to reduce this -2 to 0. So write this matrix form in equation form. So you write x plus y plus z is equals to, in RHS keep the element as it is. In second row 0 minus 3y plus 0, 0 minus 2y minus 2z. Then after equating the matrix we get x plus y plus z equals to 2, minus 3y equals to 6, minus 2y minus 2z equals to -2. Denote this as equation 1, equation 2, equation 3. Now from equation second we get the value of y. So the value of y is y equals to -2. Substitute this y equals to -2 in equation 3. We get, after substituting value, z equals to 3. Now substitute the value of y equals to -2, z equals to 3 in equation 1. After substituting the value of y equals to -2, z is equals to 3 in equation 1. We get -2 plus 3, that is 1. After transferring to right side, 2 minus 1 is 1, so the value of x equals to 1. In this way we find the values of x, y and z variables. हा व्हिडिओ जर तुम्हाला आवडला असेल तर याला सबस्क्राईब करायला विसरू नका, आणि आपण ह्याच्या ॲडव्हान्स टेक्नॉलॉजी आहेत याचा यूज करून कमीत कमी वेळात जास्तीत जास्त कसे प्रॉब्लेम आपल्याला सॉल्व्ह करता येईल त्याचा आपण प्रयत्न करू.